And we'd like to continue right there because we're now coming to the panel discussion where we want to discuss with several people, among others, you, Professor Stratmann, and this is about excellence in research. So we invite Michael Hoch and Mr. Stratmann to the stage, but also other guests that we are looking forward to, Professor Dr. Peter Scholze and Professor Dr. Catharina Scholze, both from the Hausdorff Center for Mathematics. Could you please come to the stage now? Well, Mr. Stratmann, this has been a great keynote address, reflecting many of the things that we believe is right here at the university. And it was quite impressive, your plea you made for pure science. Do you believe that in the current political discussion, I mean, we've just had elections here in Germany for the new parliament. I mean, the situation is characterized by the pandemic, among so many other things. There will be cuts. There are new projects, new things that the new coalition, the new government will want to implement. Do you believe that pure science will get enough support in Germany? One thing is clear. Without fundamental research, without pure science, the transformation of the society, for instance, in energy, will never be possible. What do you think about all that? Well, I believe it's difficult for politicians to make forecasts, but the reality usually will overtake you on the right faster than you can think. But my feeling is that basically pure science is an important and essential part of a state, and everybody knows that the programs and the support from politicians that we see now are always based on using 3.5% of the BIP into research and development. We are still set on this target, but if I look at the most recent papers we got from the coalition negotiations, it seems research doesn't play a central role. They talk a lot about innovation, that's new, and they also talk a lot about climate change, but it will be our job, I believe, to make sure really that pure science is really seen as what it really is, a central element of solving all problems. But as I said, pure science is not a toolbox. We don't produce tools to, for instance, do something about the climate change. Pure science delivers fundamental insight, and the importance of it is often seen only decades later. And this is what we will have to explain to politicians so that everybody understands. But basically, I believe Germany pretty much is convinced that pure science, fundamental science, is essential for the future of the country. I believe Germany basically with the Union of Research and Innovation is well established, but I would have wished that the universities would get better financing there. Although we shouldn't complain, maybe we're complaining at a high level, but still we must point out that there are many competing initiatives that people think about. Some politicians, Idee Innova, the German Transfergemeinschaft, the transfer union, if they try to establish it right now, it would also cost a lot of money. Evidently, people have juggled numbers like 500 million, 1 billion euros, so a similar volume that we already use for the promotion of fundamental science in DFG and other supporting organizations. And all that at a time when basically, if you look at it, financial resources are a bit scarce, to be honest. Do you believe that this development toward a, well, German union of transfer of knowledge from knowledge to application is possible at the same time, or do we have to do it one step after the other? I mean, it's just a word, it's just a catchphrase, and I'm not sure if I can really understand it. I mean, the Liberal Party, the FDP, is using it a lot. I don't know if everybody knows it, but this is tries to describe something that I tried to point out before. The question is, I mean, we're having a lot of innovation innovation, but do we use it smartly? I don't really believe that pure science is affected here. It affects more the question of how we handle support and promotion programs of the Federal Ministry for Research. And the challenges we face are pretty long-term. Energy changeover, it's something not for a term of office. You need decades for that. And one question that is really up in the air, and I've talked about that a lot, and other people, don't we need something like an agency of innovation, like DFG uses a lot of professionalism and independent of politicians can work really towards certain targets. Let me give you an example. You want to build a quantum computer. I mean, it is a target, it's an objective of the government indeed, but implementing that is not simply left to the business everyday work as it is, but you have an agency that's concretely promoting that. But it is clear that such funding cannot go at the expense of basic research. It must be a reallocation of funds that already exist, like project funds that already are being juggled, otherwise that would be disastrous. Maybe I have another question concerning the excellence strategy. You allow me maybe to ask this? We're having a situation, you pointed that out, there are 10 universities and one union, one organization, 12, 13, 14 universities of excellence, and there are 3 or 4 open slots at the moment, and there are more and more alliances at the moment. 2, 3 universities who want to go together, make an application together, so the probability that at the end of the day there will be 25 to 30 universities of excellence at the end of the day, maybe that is a possibility, right? So the question is that really a concept that you would welcome, or are you skeptical about that? I mean, if you think of, coming back to your other thought, you said something like the future, maybe the next phase of the excellence strategy should be more the concentration of universities and extra university institutions on certain research campuses or something. You gave some examples in your keynote. Maybe this is what we need in Germany, and maybe you cannot accomplish that well, or you can't do that too often. You shouldn't have too many such centers. We have great interaction at the ABCDJ axis, so the research center at Jülich, but there are not so many centers in Germany who have the potential to do that, to chime in into that. What do you think about it? I do not want to give you smart advice at this point. This is a slippery road. But anyway, let me try to summarize a little bit in those words. The Excellence Initiative, it's been around for 15 years or so. It's been a great success. It led to a situation where universities did a lot of introspective work, and there was a lot of start to new horizons in the university. Even if you didn't get the cluster, I've seen that a couple of times. It helped them a lot, and a lot of alliances that people formed are still around. That was a big success. But then on the other hand, it's always in if you do that same thing several times, you have a limit effect at some point. You cannot always have the same effect as at the very beginning. The curve becomes flatter and flatter. And I have to ask you, do we want to continue as in the past? At this point, I would ask, we have to define targets. What is the target, the objective, really? Because if you know about the objective, you know more or less what sort of methods and tools you need in order to accomplish that. If the objective should really be to compete with the big research institutes like the Chinese ones, then we know basically that's possible only by way of differentiation. You cannot believe that the research landscape with 30 excellence universities and so many thousands and thousands of students and so many professors, you will never accomplish that. Differentiation, I believe, is a must, and I would expect, I know it's difficult, I know it's hard, that the university economic world develops some ideas of their own, how, well, what the future should be. It is difficult, I know that, and you have to represent everybody, and don't be too critical about the word differentiation. And one of my two suggestions that I've made, one is strong campuses that make possible that university can cooperate and really participate in all areas, and it really leads. You cannot reach the top everywhere, but you can focus on certain certain focus points, and that's and they really try to become internationally visible in this one. The Cyber Valley is one example, or maybe mathematics here at Bonn. And the second thing is the schools that I mentioned. It's another idea. The idea is you accept the spread out excellence in Germany. You accept that. I mean, Germans are not less excellent than other countries. We're just not focused. We're spread out over so many places in Germany. And the idea is maybe that spread out excellence should be bundled in schools with a clear objective to really compete with the likes of Stanford and Harvard. And I see it works better than we thought. I mean, at first we thought it couldn't work. We're all living on the door-to-door principle with the social networks we have, the communication tools we have today. It's actually working pretty well, much better than I thought. I think we have to come to understand that the world that we're living in has changed very much. The communication world has changed so much. And then I must ask, and that would be my advice at this point. Shouldn't we use that maybe to make something in Germany, the structures that Germany has, which is not a copy of the American system, it will never be like the American system. Couldn't we simply use our strategies that we have and come to our own solutions, using all the means and tools and communication technologies that we have, deliver our own answers to the question how to differentiate in a different way than the United States does, where you have only 3 elite universities. In Germany, we have only 2 or 3 universities too that exist at the level of Stanford or Cambridge, and that would basically kill so many other good things in the German landscape, and that cannot be what we want, and that wouldn't be good. Thank you for this great, interesting discussion. It's been a great launch into the discussion, and we want to go on. I'm happy to welcome Professor Dr. Scholze. Welcome to you. And yes, in our discussion, it's all about excellence in science. And if you look at your CV, I believe you can find a lot of excellence. We probably heard the best example, of course, is that in 2018 you received the Fields Medal, the highest award in mathematics in the world. And this is my first question. I mean, that was 3 years ago that you received the Fields Medal. What has changed in your life since then? It's a good question. Luckily, my normal life has continued in normal ways. Yeah, I mean, when I was about to receive the medal, I was a bit afraid of all that publicity, but I mean, it's over pretty quickly again, and you're back to normal. And right afterwards, the University of Bonn was so successful that the focus was on the university, and I was happy about that too. And the limelight was off me. And from a scientific point of view, I absolutely wanted to continue with my research, and that's what I did. Right after I received the medal, there was a new postdoc in Bonn. We discussed, we came up with new ideas, and we continued our research in pretty good ways. That's a good sign. That's good that things reverted back to normal. Yeah, but nevertheless, it's been quite impressive what you have accomplished there at a very young age. But I read up on you, and I was surprised. If you look at the regulations of the Fields Medal, it is a fact that it goes only to mathematics who are younger than 40 years old. Can you explain that? Why is that so? Yeah, you have to ask those guys. The past 100 years, I believe 100 years ago, they thought it was a good idea to have an award for young people. In the beginning, I believe they didn't want that, but today it's a little bit the Nobel Prize of the mathematics. It was never supposed to be, but in the 1960s or so, it reverted into that direction because there was no Nobel Prize for mathematics. And then all of a sudden, there was a public demand that maybe you need something like that for mathematics, and then somebody said, okay, let's have the Fields Medal for that purpose. But basically it's more something for young academics, for young mathematics, to promote them. So there is a creativity after you're 40 years old. Yeah, there is more creativity after you have turned 40. I mean, there are many people who had their big breakthrough after their 40th birthday, indeed. No, definitely. It's a funny thing. It has to do with history, with traditions, this award. Yeah, but it's interesting to hear how things have developed over time. In any case, I believe there are many more open questions in mathematics that a lot of people should look into. What would you say at this point, looking at the future, which are the big open questions for the future of mathematics? There's so much. Very prominent. If you look right now, if you in 2000 there were the so-called Millennium Problems, 7 questions. It's about very different things: the stability of flow mechanics, a practical problem, or theoretical. The phi equals m problem in informatics, but there's also abstract mathematics that has a lot of questions. The Riemann hypothesis maybe is the best known, and already in 1900 Hilbert proposed this as one of his 23 problems to solve, and most of those 23 problems have been solved in the past 100 years, but the Riemann hypothesis is still open. So that's, again, there are many challenges, many interesting questions in mathematics that are quite essential, actually. It's all where we've been working for so many years, but we have seen very little progress. It sounds exciting, so a lot of work ahead in the future. What about my last question has to do with digitization in mathematics. We've heard, and during the pandemic, we have seen so much progress in digitization. What do you see in mathematics? It's an interesting question. Myself, for me, the computer only plays the role of a typewriter to write, for writing emails and for writing my reports and my papers. But I don't use it for calculating, for mathematics. I mean, some people do that in order to do complicated formulas. I work with my pen and paper, really. I'm quite modest in that respect, to be honest. In any case, it's interesting, nevertheless. Yeah, sure. I try to find proof, evidence. So I tackle very abstract structural problems, and computers usually aren't a great help in that. But right now, computers really break into this domain in current research to really be able to test on the individual steps of evidence, of proof. In the meantime, it seems to be possible for the most recent research. And there are teams like at Google who can now, computers that can play chess and Go, who try to do mathematical proving. It's absolutely impossible to say what will happen in the future, but it's interesting. And we're all really looking forward to that. And I thank you for having been here, and for your future, I wish you all the best. Maybe that things stay normal and don't change so much, and I leave the floor to my colleague. Yes, of course, we stick with excellence in science, and let's now discuss the excellence cluster in mathematics at Bonn University and the Hausdorff Center for Mathematics. And I now talk to Catharina Stroppel about all that. In 2006, the Hausdorff Center for Mathematics was founded. It's been extended twice, last time in 2018 for another 7 years. Personally, I'm not a mathematician. I don't really have many friends from there, so I had to read up a little bit on that subject matter, the HCM cluster. And the objective of the cluster is the cluster wants to make a significant contribution to mathematical challenges of the 21st century, identifying them and solving them. And I ask myself now, what kind of challenges can it be? Have they been identified in the meantime? And the lady is not on the microphone right now. It's a long way to identify things, and I believe we haven't managed yet, but we are doing it right now. Okay, the first thing that I found fascinating, and one of the reasons why I actually came to Bonn, is the new excellence cluster, which reflects the entire bandwidth of mathematics. It's not just pure mathematics, like I knew it in Great Britain, where I began, but also applied mathematics is in a totally different institute, and no, it really reflects all of aspects of mathematics, and many problems can be solved only, I believe, if we go away a little bit from pure mathematics, go into applicable applied mathematics, and into the implementation of mathematical ideas, where everybody comes together. But then, on the other hand, also go a little bit deeper. Peter Scholze, I believe, is very extreme when it comes to pure science, not so broad really, that he wouldn't really discuss with the numericals, at least not voluntarily, but the entire breadth, the entire bandwidth of it. And then you immediately see the problems on the table, and we try to identify that. And where does the excellence cluster in mathematics stand today? Or put it differently, will there be more support, need for support in the future? What do you think? Okay, coming back to another look back. You said it, in this cluster was first applied for in 2007, and the idea was we need a visible center for mathematics in Germany, and that's totally different now. We have built up many pillars, from support of students all the way down to the postdoc school to a program of the so-called Bonn Junior Fellows, which are B2 positions where we call in at the international level, and we want to compete at the international level right now. We heard that a couple of times in the discussions. That means we're trying now to really compete with the United States, with the top universities. And that's different than it was in the beginning of the excellence cluster, and different challenges really. And you can imagine, once you start to compete at the international level, you need financial support. Obviously, we cannot simply say, okay, this is over now, we've managed everything we wanted to manage. No, we have to continue, we have to go on. And I believe we've now come to a point where we have to really not just be visible at the international level, but really maintain.
So, one more thing I would like to mention. So, funding of young talents, young scientists, and then one more issue regarding the genders. How about this? How about the gender issue? So, how could we make mathematics more attractive for women here at the university in Bonn? Because right before we saw that the share of women here in Bonn is not very high. How to change this? Well, the first thing, recruiting women. That's the first thing, in a positive way. What we try to do in mathematics at the Hausdorff Center, so we try to apply a proactive approach. We try to address women, and we ask them to apply. It worked out well several times. We recently recruited a very competent person, a very competent woman, and what I realized, so the two-body problem, from the point of view that women sometimes have to follow, that men sometimes have to follow the women. The other way around, it's true too, but sometimes this is neglected. What I want to say, for women, very often, so funds are made available as a second body, but for men, it is not that much developed. So, well, now we have many new students in the mathematics department. What kind of advice would you give to them for their career in the fields of mathematics? Well, my first advice would be, well, listen, it will be hard, it will be tough, but on the other hand, mathematics is on a good way. You may say to the other people, you are not right. You may discuss it openly. It is attractive. So a crucial objective is the promotion of young talents, scientific talents. So what characterizes a good system for the promotion of young talents? From my point of view, it is important to be in contact, in touch with the young students as a scientist, as a researcher, and as a lecturer, as a teacher too. Regardless of the level, you have to conduct them to interesting issues and questions and matters, and then they may start to act. Then they may try things out. The personal contact is very important, and in the area of mathematics, very often we have lots of contacts. So we have a good system of follow-up and help. And on the other hand, they have to learn how to work autonomously. That's even more important than in the past. We offer so many different programs. There are so many different fundings. but educating the people to be autonomous. So sometimes this and to work autonomously, sometimes this is neglected. Thank you very much for these very interesting comments to you all.